welcome here, Jordan. We'll do the proper introduction later, but let's just continue quickly with the news and Apple's big developer conference, and they seem to have done really well in terms of engineering in the AI into the operating system, into the applications. It seems to be really like seamless kind of use of AI. Have you followed that in any way, or?
Yeah, we've Apple, I've been following it as a personal consumer, having an iPhone for a long time, and of course followed the recent announcements. The latest thing with the models is very interesting, where they have this hybrid approach where you can run models locally on the phone, Apple Intelligence, as well as being able to optionally connect to ChatGPT.
And it seems to do it in a automatic way, right? So it has some kind of smart way to know now you can run it locally on the phone, and now you need to go to the cloud to do the compute, right?
Exactly. Yeah, I think there's trade-offs. So when we saw the GPT 4o demos from OpenAI, there were some people saying that effectively they were running two models: a small model that would respond immediately and give a audio-based response where you could hear things like it's thinking, it's saying it's repeating your question back to you, and then the larger model is actually providing the full response later. Right. And so I think that was the most popular demonstration of a hybrid approach where you could have smaller models working with larger models. The fact that Apple has done enough engineering to get this to that point where they feel comfortable rolling it out to their billions of users is pretty incredible.
Hey. It is, yes. Now we have Henrik here as well. Now it's actually, I used to work at Spotify before, and they have a similar thing. They want to have like a very direct, user experience. When you actually click play, you want it to start playing directly. That's why they have basically catched using CDNs, the first couple of seconds of the song directly. So you can play that very quickly, and then it seamlessly goes over to the full song that is stored in their master storage in some way. And it seems like, OpenAI is doing something similar, small model that quickly starts to respond. And
the biggest thing I've seen when developing enterprise grade language model applications is that a lot of people use them for simple things they could do without a language model. We heard about this with the use case with Klarna using OpenAI. They talk about how many of the support tickets they were able to automate with a language model. I mean, comments from engineers that I've heard who have used this software show that it's really just a display of an existing document that's in their database. Right. And the thing the model is doing is providing a better user experience and a bit of a guarantee that you're going to get a nice response. But this is something, from an information perspective, it's not too complicated. A lot of people use Siri to, start a timer, make a phone call, and extending that a little bit to be able to order an Uber ride or order a delivery meal or book a haircut. That is something that you could probably do with automation, right? And if you use a small language model and you get the same outcome, that's great. But the user experience of having a personal assistant, which is capable of giving you small, quick answers, and then also large, more complicated ones if you need, I think that's a pretty powerful concept. Yeah.
And also very much more, cost effective, because you don't have to run the full model all the time. So you can just use it when really needed as well.
Yeah, exactly. We see this being applicable. So I worked on an application that was used in the federal government, effectively, where you could see that there's an aspect of translation in certain cases, and we had some conversations with banks who wanted to do this as well. You'd imagine that whether you're flying around an autonomous drone or you're somebody walking into a bank, you may want to interact with the system in your native language. So somebody who's Spanish and living in the southern U.S. Goes and asks a question in Spanish, and for example, having a model that runs retrieval on documents about that customer in English would require first the speech-to-text transcription, then the translation to English, then the retrieval of the documents, then forms a chat response, translates it back, outputs it back in audio. We're talking about 5 or 6 models for one experience. It seems pretty powerful to be able to shortcut a lot of those initial responses, hide to the user that a lot of processing is going along in the background, and provide provide a quick response, but also save money, right? Because I think, like you said, cost and potentially also data security will be considerations where certain requests that are deemed as, illegal, like you have to filter them out, or you need to basically just error out quickly. Saving an API call to generate 1 million tokens is that's going to save everybody a lot of money. Yeah.
And with billions of users, that will be a lot of money saved for sure. And welcome here, Henrik. You managed to get through the rush traffic.
I've been north of the city, like in a car ride 20 minutes away, and it was a good 1.5 hours.
Jesus Christ.
And it was like bumper to bumper, 5 kilometers an hour. I find that more stressful than if I'm late and I can speed. Like when you're late and you are not able to go with the flow, but you're stuck somewhere, I find that more stressful. What do you think?
Yeah, I think when you have more control over how late you are, that gives you an illusion.
Yeah.
That's preferred.
Yeah. So sorry, guys. Sorry, I apologize for that.
We need Elon here to Stockholm as well to build some tunnels.
We need to build some tunnels. That's for sure.
I heard great things about the train. Last night, I got off a flight coming into the Stockholm airport. We got into a taxi, and the driver, within about 5 minutes, told us he needs to stop for gas. So maybe we need him here for some even more electric vehicles. I thought there was enough here, but there's
more electric vehicles, more tunnels, more trains.
We'll change the taxi service in Stockholm.
Yeah. Autonomous taxis. Let's go there as well.
Yeah, I like that. Yeah.
Just of course, before we do an introduction to you as well, I'd just like to hear your thoughts about Jan LeCun versus Elon Musk kind of feud like 2 weeks ago or something. They, to my understanding, I think it was Jan that commented on some kind of recruitment ad on XAI that Elon Musk had, and it's something about if you want to have a boss that is blah blah, and he basically spewed a lot of.
He made a roast.
Yeah, he roasted Elon Musk.
He roasted Elon hard.
And I think one way, at least, if I were to guess, is they're basically fighting about talents and they want to have the best talents coming to Meta, and then of course Elon wants to have them going to XAI.
It was a feud on definition of science and stuff like that. But we all
continue to that, yes.
But we all believe underneath the whole thing is like let's roast him so we get the talent to us instead. That was our cynical analysis of the whole debacle.
The whole continuation of Jan speaking about what science is and that you shouldn't control scientists and everything. I think all is a play for getting the talents in. Do you have any thoughts on this, Jordan, or have you followed the feud?
Yeah, I mean, I can speak from a personal level, right? I did not do a master's degree or a PhD and still feel like I'm making some contributions. And a lot of people will guard the advancements of the industry and say only scientists with PhDs who write research papers and know LaTeX and publish on archive are the ones making advancements. I think it's pretty obvious that both are required. Like you need people doing research who don't think about whether the research they do is going to be popular and widely adopted because they focus on very specific things. And then you also need people to drive the advancement of new technology. Like I'm very thankful that Elon is
But this is perfect. We have one good question that we need to add to the list here, Anders, where we had discussions and argument. What is science versus what is engineering? And where do you do research? Can you do research from both angles? And I think that's what we're talking about here.
Yeah, we could add it to the list. Actually, that's an interesting topic.
Interesting thing to get for someone who's in the middle of it.
Yeah, when I was growing up, my favorite comment on this was from the show Mythbusters. Yeah, you guys remember that show?
Yeah, of course. Still watch it.
So Adam Savage had a line in that where he would look at the camera and say, "Remember, kids, the difference between science and fooling around is writing it down."
Awesome. Awesome. That's another T-shirt.
The difference between science and fooling around is writing it down. I love that.
Yeah, that's great. With that, I'd love to welcome you here, Jordan Nanos. Is that the correct pronunciation? Yeah. You're basically a machine learning architect. Is that the right role at the Hewlett Packard Enterprise?
Yeah.
And you just arrived went early from a workshop that you have here in Stockholm, right?
Yeah, myself and my partner in crime, who I think is coming later, Cyrill Hug, we were doing a workshop with some HPE customers and prospects, showing them how to use our software, how to design clusters of GPUs and storage that you need to build AI systems. And we're really focused on self-hosted generative AI. So like guaranteeing privacy. Yeah. On-prem for sure, yeah. But we also, the workshop was sponsored by a company called Taiga Cloud that's based here in the Nordics and has, they build their cloud using HPE technology, but it's on demand, just like something from AWS.
This is a virtual private cloud now. So like we have all these use cases where you, for different reasons, cannot go public cloud, or for different reasons is maybe doing something on the edge or other dimensions where you really need to have your AI physical.
But can you elaborate a bit more? I mean, on-prem is one thing you said, but otherwise, self-hosted is the reason for that. Even if you use like a normal cloud provider, is that you want control, or what's the purpose of doing it?
I think control, but why would you want control, right? There's three big things. I think the first thing is cost. So the current model for generative AI is to pay per token. Right? And I think this breaks down pretty clearly once you as an organization are using more than one model copy's worth of tokens in a given month or hour or whatever metric you're using, which is to say paying per token means you're doing serverless, but as soon as you're using more than one server, the reason to pay per token kind of breaks down, right? And so you're paying a significant premium to pay per token per million output tokens or million input tokens, as opposed to just hosting a model yourself. And that's the first thing we've seen is like the cost of using OpenAI's endpoints scales linearly. You don't get a discount as you use more. If anything, you get capped. You can't use more. The second thing, of course, with control is just privacy and security. Many people don't want to expose their data. They're not comfortable with the terms of service. Right. We've seen this response from the Apple announcement we were just talking about, right? And then I think the third thing when you think about control is the performance of the model. So many people are looking to fine-tune even the latest OpenAI models because it
performance in terms of accuracy, not really like inference speed. Or
I would actually say both, but I would focus on accuracy or quality of the response, right? If you want the model to call a function or have some guaranteed output structure, there's things you can do to fine-tune their base model, but Apple's example, running the small language model on the phone, right? That's both faster and likely better performance because they can guarantee when a user says a certain keyword, they're going to provide a certain response. They're going to output in JSON format and call a function, for example.
But hosting it yourself has this drawback as well. I mean, you need to have the competence then how to do these things, right?
Exactly.
Or use HP, I guess would be your response.
Yeah, you need to have a partner to help you along the way.
But all this is, of course, I mean, like we are early on in the path here, and we're gonna have more and more simplicity and more usability in the cloud approach, in the token approach. But I would assume also in the self-served approach or the on-prem approach that, I mean, like you've been doing big leaps in terms of the software and the orchestration tools that so. Before you had to be really, really good coder on machine level, and now, so I think there's a lot to talk about here, where we're at on this.
Yeah, the first thing that we as an organization are beneficiary of is just the benevolence of Meta and Mistral and other companies that are releasing base models, and how initially with GPT-3 and then 3.5, there was a big gap between proprietary and open source. And now the gap is very small for Llama 3 7dB. And with the upcoming release of Llama 3 400B, I mean, what gap really is there left? There's multimodality. Most enterprise customers are not interested in their very first application being a advanced multimodal agentic sort of thing. It's more the simple stuff. And Llama 2 70 is plenty good for that. But to your point, yeah, the usability is crazy. When we got started, people wanted to teach machine learning engineers, people with PhDs in statistics, Kubernetes. It's like, maybe that works for some people, but not for most organizations. Yeah.
No, but in the beginning, you really need to be a full stack engineer. You need to have very complex team structure to do all the different bits and pieces of a production system. And this is now getting more. I mean, like we see where this is going. Simplified, hidden behind stuff. So you need to be an engineer most likely, but not not the unicorn engineer, maybe.
Yeah, exactly. Yes. You at least should have specialization. So I think as the team grows large enough, there's room for a platform engineer or an architect who works on building the platform that people are going to build the many generative AI applications on top of. But when you want to get your first one rolled out in an enterprise, having the prerequisite to hosting your model being setting up a Kubernetes cluster, learning how to run VLLM, building a log database, it's like, that's just too much for...
It's hurdles.
Yeah. Exactly.
Perhaps we can get back to the HP platform or a solution for this a bit later.
Yes, sure.
It would be awesome to hear more about how we can basically, I guess, fast track or quickly get started with using LLMs on
We're
the
going to say
HP
something
stack.
with Cyrill as well, right?
Yeah. But before that, once again, welcome here, Jordan. And perhaps you can just elaborate a bit more or speak a bit more about who is really Jordan. Can you just elaborate a bit more your background, your passion, your interest, and how you got started at HP?
Sure, yeah. So I guess I started at HPE in 2016 for the first time. I joined right out of school. So it was right into a sales organization. I joined in Toronto, in Canada. I'm Canadian.
Oh, really?
I was working out of the Mississauga office as an intern. And then, from there, I held many different roles across the organization. So I started out in a general pre-sales role where I was helping people install our technology in a demo center and learn a bit about it. Basic hardware stuff. I then moved on to the high performance computing team. We acquired a company called SGI in 2016.
Of course, SGI.
And there was a sales rep covering Canada who joined the team, and she needed some help on the technical side. So I was covering the whole country with her. Susan Kramer is now retired. I moved from there, wanted to get more into the software side, AI. So I worked for our Esmeralda software business unit, which was formed after the acquisition of a company called Blue Data and another one called MapR.
Yeah, MapR.
MapR, the original.
It's not
guys over here.
Is that like brand available anymore, or is it completely integrated into HP now?
So it's been rebranded to HPE Esmeralda Data Fabric. MapR still has a kind of two products: the file and object store, which is just an HDFS style file system. The MapRFS, so much more scalable and better, we would say. And then the ecosystem applications. There's still many people running Spark on Yarn or Kafka at scale or HBase at scale. And
the first generation data lake stuff.
Exactly.
Not the first. The first would be Hadoop, right?
Okay, Hadoop is the first, I guess.
Exactly. Yeah. Well, there's still support for drill and Hive tables and stuff like that. So
Hive.
Yes. Uzi, I don't know. This stuff's out there and people want support. So sometimes they come to MapR for support. But most of that organization is now a Kubernetes product where they run, Spark at scale or Kafka on Kubernetes or Airflow, stuff like that.
Yeah, awesome. Okay, and your current role is what? Can you just elaborate a bit more? What do you do at HP these days? Yeah,
in the fall of 2021, there was a bunch of changes in AI, and I basically moved into a global CTO office role. So my boss is our chief technologist for the global sales organization, Scott Wiest, and there's a few other members of the team. We basically work around the world, engaging with customers. I focus on AI. Other team members do some AI stuff, some other specializations, and we work as sort of a field-facing architecture role where we help customers design. We really focus on the new stuff that HPE is doing. It's not, many people hear this and say, oh, you work with the big customers, and it's really not true. We work with the customers who are doing stuff with the technology we're just introducing, the new stuff. So I've been working a lot with a software portfolio of two other companies we acquired called Determined AI and Pachyderm recently. And that's what we're here, talking about on this roadshow, showing people how to use that software.
Yeah, perhaps that's a good next topic here. So you basically are doing like a roadshow, you're saying, around the world in some way, or in Nordics, or in
Europe. Yeah.
Europe.
Yeah.
So please elaborate. What's the roadshow?
Yeah, helping people, first of all, learn that HPE has some software that could be useful for AI, and then second, how to use it. So last week we did Munich, London, Amsterdam, and then this week we were in Zurich, yesterday Milan, and today here in Stockholm. So
that's a good road trip. That's worthy of a rock star, I think.
Exactly. Yeah. Yeah. We so it's me and Cyrill presenting. Cyrill is originally from Switzerland, so this is all he's been all around before. But for me, 4 of the 6 cities I'd never been to. I've never been to Stockholm before, so seeing the world with work, it's been great.
How long are you staying here in Stockholm?
We leave tomorrow morning.
Yeah, and is that back home, or is it still going on the road trip?
Back home.
Back home.
I'm back home for 2 days, and then this coincides. We also have an annual conference in Las Vegas called HPE Discover. So that's our big time to get the team together, and I'll be going to Vegas next week.
Is that with partners as well? The one in Las Vegas is fairly big, right? That's the big one.
It's the biggest one we do. Yeah, partners, customers, everybody. Our CEO is actually going to be in the Sphere giving his keynote with the CEO from NVIDIA, Jensen. So not just partners and customers, also the Grateful Dead and John Mayer will be joining us.
Look at this. Yes, you still know how to do this best. No one else comes close.
You want to drink?
A beer?
You got some local Swedish beer? Yeah, I'll do a beer.
Yeah, I do want to.
Okay, so what do you do on the roadshow? So you came here, I guess, today, this morning, or yesterday, or
last night.
And then you're doing a roadshow or some workshop. Can you just describe it a bit more? What do you do at the workshop?
We called it the roadshow because we're going to multiple cities, but in the venue, it's a workshop, which means that we just invite people out who are, customers or potential prospects from HPE, some partners, and we thank you. We show them how to use the software, basically. So there was 4 sections of the roadshow. The first one was a demonstration of how to run your first language model on a GPU server. Try to simplify some of the stuff we were talking about earlier. I show people how we design GPU clusters. So starting with your first GPU server, all the way up to supercomputers. Then we go to another demonstration of building a retrieval augmented generation application.
The RAG.
Yes. So show that, and then talk about how we use some of the other platform software. So the Pachyderm stuff where we do data processing, and new software that we have in private beta called MLIS, where we do serving. And what they're doing right now is hands-on. So the very last section is a fine-tuning lab, where we show, again, a new product where you can fine-tune a language model without writing any code. Just provide some data and a prompt that you want to use, and then you can fine-tune the model to perform that task. So
cool. So many angles here, but perhaps you can, I guess you are doing some of the software yourself, and then you're using a lot of open source tools like Pachyderm, etc. Can you perhaps describe a bit, what's the tech stack that HPE is providing to help you build and serve generative AI?
At the basic level, like a container runtime like Docker and orchestration software like Kubernetes, we kind of depend on. We acquired Determined AI in August of 2021 and Pachyderm in January of last year.
Oh, you acquired Pachyderm as well. Oh, I didn't know that.
So both of those companies still maintain open source projects, a few thousand users for each. And, many of the engineers who built it work at HPE now. So we, continue to drive those projects forward. But the enterprise version of the product, which is what we're showing, that has things like single sign-on integration, role-based access control, in Determined's case, integration with Slurm instead of Kubernetes, if you'd like that.
Yeah.
In Pachyderm's case, some examples of using the NVIDIA Rapids framework. Those are the kind of 2 basic pieces that we employ and have been doing for a little while now. The new one, MLIS for serving, for what we've seen for serving models is that people run out of capacity on one container, one GPU, and so they need to auto scale up and down and do load balancing. So we're using a framework called Kserve, which was originally from the Kubeflow ecosystem, primarily maintained by Bloomberg now. And we've been building effectively a front end for that with some specific features for serving LLMs that Kserve doesn't have right now. I think it's coming to open source, but basically the model endpoints are not OpenAI compliant. So we added that.
So you could describe it like the HPE kind of tech stack is like a distribution similar to like Ubuntu has a distribution of preferred components in it that serves as an operating system. You can say that you have like a platform or AI platform or tools.
Yeah. I mean, each of these 3 tools I described can be bought and run individually. It doesn't need to come together. But most organizations that we're working with want the full end-to-end platform. And so, yeah, there's effectively a distribution. The open source for both Pachyderm and Determined releases every 2 weeks. So it's, considerable velocity for development there. And they have a lot of users testing it and making contributions. So I think it's less of a firm cadence for upgrades the way Ubuntu would have, 2204, and then many times later they're now rolling out 24. But it's a recommended place to get started for sure.
But one of the thoughts I've had is I think there is some sort of engineering or data AI divide out there between the Klarnas and the Spotifys and more traditional enterprise. And so there's some sort of skills gap here. It's like not enterprise is not good enough to go all the way down hardcore into open source, and then we are trying to package it to a place where normal engineers that we can find out there can kind of use this, even if they have no real deep learning or neural background. So where would you say, the question is, where would you say we're at right now in terms of what is the sort of prerequisite skills level you think you kind of need to be at to really get going in your ecosystem? I would assume you can't be a complete newbie, because with the stuff we're talking about, you kind of need to know what you're doing. Yeah. But at the same time, to go from scratch, as we talked about, that is way harder, right? So how would you define sort of the prerequisite engineering skills that you kind of think is a good starting point for going to your workshops and starting working with your tools?
So the prerequisite to start working with the tools is, I think, you have to be a developer who's willing to write Python code today, and you should have some familiarity with the concepts of Kubernetes and scaling and working with GPUs and things like that. If I view it from an organization's perspective, who's considering working with HPE, we always frame it as build versus buy. Are you going to buy your Gen AI strategy from somebody who's just turning on a feature in a product? Yep. Or are you going to build it all custom for yourself? And there's this thing in the middle where you build with help. Cyrill's got this great analogy. He's a car guy, so he works on cars all the time. And he basically says, you may want to improve your car, fix your car, like upgrade it, but you shouldn't be building wrenches and diagnostics tools and things like that. So it's this thing in the middle where, maybe there's some things you buy. You license GitHub Copilot, right? And that's a great experience. You could probably build a developer assistant in the data center, but if you're prepared to use GitHub Copilot, why not just pay whatever, $8 a month per developer or whatever it is to get going? And then there's these other things on the other side where, like, for instance, at HPE, we have descriptions of all of our servers, the technology. We call them quick specs, and we're building an application to allow users to chat, ask questions. How many GPUs does this server support? Compare this server to the other one on performance. And in those cases, like, that data that we want to use to build the application, there's a lot of servers that we haven't announced publicly, we haven't released. We're not going to expose that data. And so we're just kind of building that all internally, really having full control. I think there's a lot of people that are similar to us in that they got started with users using Gen AI with something they could buy, and now they're learning how they can build stuff. And so as you can probably build your first one without any help, right? There's lots of really good tools out there, open source documentation. It's how I learned. But when you start scaling, like, I have multiple users, I have multiple applications I'm trying to build, big cluster of different GPUs. Now you probably don't want to be focusing on
the infra all the way.
Exactly, yeah.
But I toyed with the idea, like is this classic make or buy conversation. But I found that we are now, when we're getting into more complex stuff, like the choice is one way to define it differently is is it like a buy to make? So it's, so it's not that simple. So make or buy. It's like, okay, no, we need to buy some stuff in relation to HB in order to simplify it a little bit. Then we can make something that we put in production. So what do you think about that? Because I think you're describing a buy to make.
Yeah.
You see what I mean, right? So there's this middle ground somewhere.
Yeah, you can, I think, so let me make an analogy to computer vision. A lot of organizations basically purchased a model as part of a software application for computer vision. They're a retail store, they want to see who's stealing things, or they're a manufacturing customer, they want to sort things with an overhead camera. What they would discover over time is they wanted to improve the performance of the model itself, and so they needed to train it on their data. So now they take something they bought and they needed to customize it. That, I think, is similar to where we're at with LLMs, where nobody is really pre-training models today because you just download Llama and it works. But I believe for most enterprise applications, we're going to need to fine-tune. And we already saw that dynamic for computer vision or for recommendation systems or for things like that. The only difference now is that the open source models are so good, you don't actually have to buy them, right? And so what are you buying, or where's the skills gap? If you have somebody who knows all about the business and can focus on how the business is going to use the model, the skill gap is improving the model over time, updating it. And that's where we describe the tools. So the tools to improve the model are where
so it's not the models you actually buy, it's the plumbing around them to have the infrastructure basically necessary to serve and train them.
Exactly, yeah, I think so.
Yeah, and this to me makes a hell of a lot of sense. We had Kasi Kusorkov on talking about the model as the brick in the brick wall to build a production system. You have, so what goes into putting something in production that is safe and scalable and all that is kind of a lot more, even if it's an LLM that is very powerful. So I think that's then all the plumbing or all the stuff around this here that maybe before it's like Lego, right? Before you needed to go and build the whole thing with very small Lego pieces. Now we can have a little bit fewer blocks, like more Duplo.
Yeah, I love the idea of like building things with blocks that are repeatable. So Lego comes to mind. The other analogy I find useful here that I think is a bit forward-facing with technology is that the model itself seems to me like the operating system in the previous version of cloud. Like in the past, you started with bare metal servers and then you virtualized, and now you could have units. And so we would scale by creating new VMs. And each time you might use a different OS or you might have different libraries installed. And so that's kind of the way you scaled out. And then people started making Kubernetes clusters or kind of platform level applications, and that was what they deployed. And now it seems to me like the model is the unit we scale at, the operating system effectively, where one copy of Llama 3 could power the chatbot for documents with RAG, it could power the developer assistant, it could power the blog post writing thing.
And then we need to tune it to these different use cases.
And now it's a different operating system image.
Slightly different plumbing needed for this versus that.
Exactly, yeah.
And, I hear sometimes companies say, well, what do you need to buy these kind of services or cloud services? You can just download from GitHub, the Llama 3s and whatnot, and then run it. What would be your response to that?
You can't. So my favorite quote about open source is free if you have the time.
Okay, good. That's a great quote.
Yeah. So anybody who's been in the hell of trying to install NVIDIA drivers or like dig out of some Docker runtime error when they have never run a container before can probably understand that, like, yes, I could spend more time doing this, but maybe it might make sense to have a partner to show me how to do it who's done it before.
The time, but perhaps also the competence in doing it, right?
For many engineers, I think that's the same thing, right? People believe I could learn this if I spent the time, but why not hire somebody who's been doing this for 5 years, right? And that's a bit of in my experience, it's like, okay, at the scale of, I see 10 to 1. So 10 people building generative AI applications to one person who knows about Kubernetes, right? Before you get to 10 people, I would not hire somebody who's a Kubernetes expert. But at a certain point, that skill set is really important because suddenly the plumbing is what's slowing you down and not the people's ideas or their skills at that level.
Well But I think it's a profound quote. Open source is for free if your time is for free.
Yeah, if you have the time. Yeah,
It's
a great. But in short, if you summarize, I guess you are saying that open source, just downloading doesn't work. It does require the time or competence to actually know how to serve it.
Yeah, for the right people, it's that simple, right? But then you need to be on a very high level and experience with using open source. And even then it's tinkering.
Open source is one. I would say AI is another. Having the ability to fine-tune a model requires specialized skills and tools, and the same with serving. So even if you're an expert like back-end and front-end engineer, it doesn't mean that you can know how to train or serve an AI model.
That's true.
Yeah, people will object to this and say, I don't want to buy something. I want to learn it myself because I don't want to have a dependency.
Right.
Okay, if I use this tool that makes it easy, now I don't know how to do it myself and I'm not flexible. I think that's generally true. People are scared about being locked in, and okay, fair enough. So you want to be with somebody who has an open platform. I think effectively the least open is the model endpoints, where you're completely dependent on OpenAI changing the model that's powering your service, and they could change it tomorrow, or the endpoint could go down and change the price, and suddenly your business is there's concerns there. Public cloud vendors, you pay a significant premium to use their service, and then you have to pay a lot of money to remove it if you want to move to somebody else's. So open platforms on the software level, I'm a big fan of. The other thing that I think is interesting is just when you want to do it. So when I started working with language models in like May of 2022, we had our first RAG demo done. It was like GPT Neo X, 20 billion parameters, the biggest open source model anybody had ever seen. And right after ChatGPT, things like VLLM didn't exist. Kserve had no support for LLMs. There was really, the transformers library existed, but there was no, advanced memory stuff. The H100 GPU didn't exist. There's all sorts of stuff where, okay, if I sat there and didn't do anything for 2 years, and now it's May, June of 2024, suddenly this stuff is a lot easier because other people figured it out, opened up the documentation, and now I can learn. The objection I would have is, well, most people don't sit around for 2 years and do nothing, right? They're going to learn about something. And so what are the things you want to be learning about? Do you want to be an expert at Kubernetes and file systems and interconnect networks like InfiniBand just to run a fine-tuning job? Or do you want somebody to help you learn about how to use the transformers library, run the job, make it scale? And then, okay, 2 years from now, you discover, I really need to get into the depths of the nickel library and understand things. Sure, fine. I don't think that's going to be the case. I think we continue to move up in layers of abstraction over time. Even some of the most, detail-oriented engineers who work on the Linux kernel are using others' packages, right? There's layers of abstraction that are built into the basics of the Linux kernel today that didn't exist 10 years ago. Right. And people take it for granted that we can do some of those basic functions. I don't know.
But maybe you guys have already talked about XE utils. There's a profound learning topic here. As an engineer, thinking about where we are now and where the trajectory is in the next couple of years, on what abstraction level do I want to really invest my time and expertise and become powerful, right? So your argument here is a little bit like, I want to be a super engineer, so I want to know the stuff on machine code level. Well, good luck with that, right? Mm-hmm. So then you've gone deep down in abstraction level to be really useful. But because this is going to be a moving target, right?
Absolutely.
So that's really to set yourself up for success in the next 2-3 years, to ask yourself, what abstraction level do I want to be an engineer at? Is a fairly big important topic.
I think it's a matter of preference. So I've seen people going the other way recently, where everything for them in their job is about LLM performance. And the better, meaning time to first token or inter-token latency or something like that. And it's super funny to me because now people are learning CUDA. Right. And I had somebody describe this to me. So I was talking to somebody who works at NVIDIA, a friend, and we were at the conference SC Supercomputing back in November. And he told me, CUDA is a really powerful ecosystem, right? NVIDIA has 40,000 CUDA developers.
Right.
I went, 40,000? That doesn't seem like a big number to me. Honestly, right? We're talking about OpenAI, who has 180 million users of ChatGPT, $3.5 billion in revenue now, I think. Like that's the users is the biggest circle. And then the smaller concentric circle is probably the people who know PyTorch or the people who know transformers. I go look at videos on YouTube, learn PyTorch, and they have like 5 million views, right? There's lots of people writing PyTorch. And then this small little middle circle is the 40,000 CUDA developers. Maybe they've added a few thousand now that people are interested in going CUDA mode with Mark Serafin and the PyTorch team and stuff like that. But
it's certainly for very few that actually go down to that level, even though I think it's fun, I must say.
Robert Luciani, we had Robert here a couple of years back, big CUDA fan, and we have, so there are people who are really going all the way.
I guess it's like the machine code for AI. Basically goes to CUDA code.
Yeah.
So, but I don't think so, because let me make a point here. I think that there's potential that CUDA gets replaced in certain ways, and there's different angles this can happen. But the Triton programming language from OpenAI, they're going to add an AMD backend, and now it doesn't really matter if you learn how to write at that layer of abstraction. Many people report, and I've seen it in use working with Jamie DeBoren, the chief scientist at Titan ML, which is a serving runtime, right? He writes code in the Triton programming language, and he outperforms custom CUDA kernels from people, right?
That's interesting.
I mean, also PyTorch. I mean, they have the AI AMD specific backend as well. So
yeah, Torch 2.0. You've got the company Modular with the Mojo programming framework. A friend of mine who left NVIDIA recently went to work there, and they're completely focused on having a inference runtime that would be portable.
I hope we get as independent of CUDA code as we do for machine code in some way, right?
I agree.
But my point is super important now. It's not a matter of which abstraction layer you end up going, but you need to be super conscious around understanding which abstraction level will you want to bet your career at.
Yeah, you can't do it all.
You cannot do it all. No. So you need to kind of consciously think about what abstraction level is my forte, or where is the opportunity. And now, CUDA, maybe not, right? One level up, or, depending on what you're doing, of course.
Yeah,
and depending on where you are working in the stack, of course.
Yeah, Peter Thiel had a comment about this too. He said that the future is going to be for artists and science, like people at the highest level of abstraction. And I found myself recently doing a lot more work in PowerPoint than in VS Code, which is not a good thing. But.
So this is a scary point. Like, so there is an old joke. How do you know this guy is an expert? Or was it written in PowerPoint or in Python? That was the old joke. And now we flip it. The highest level of abstraction of coding is PowerPoint.
Oh my God. Sound good.
That doesn't sound good, boys.
But I guess we're moving there, using LLMs for coding as well, and starting to program in natural language, perhaps more and more.
I see a lot of people insult PowerPoint. Jeff Bezos went on Lex Friedman's podcast and said nobody at Amazon uses PowerPoint. It's a sales tool. How else am I going to communicate these ideas? I don't get it. I'm going to use what? Diagrams only?
A memo approach according to Bezos, right?
Yeah.
So fun. Perhaps we could do a bit of a switch of topic here, and if we were to move more into, for people that perhaps have bought the model or used an open source model and they're really interested in fine tuning it, can you perhaps start to elaborate a bit more, or start from the workshop, perhaps even better? What do they need to think about to start fine tuning a model for their use case?
Yeah. So, the first thing I think is that you need to identify a way in which the model is failing. So if I can make a general statement about this, in the past, people would be like, I want to learn a new programming language. And the recommendation that always rang true to me was, well, you need a project to work on that motivates you to learn the programming language. Otherwise, go read the textbook, go read the documentation. Oh, you want to learn C++, like why, right? So why do you want to fine tune a model? Because you hear people saying fine tuning models is fun? Probably because an existing open source model or existing open source fine tunes are not good enough at a task you want to do. So the first step is go make sure that of the 600, 700,000 models on Hugging Face, there isn't something that already exists to do what you want to do. The second step is to identify exactly the way in which the model is failing. So the simple one that we use for the demonstration at the workshop is a fine tune of a model to do a multi-class classification problem. In our case, we're inputting a medical transcript. Imagine somebody visits the doctor and the doctor took some notes, or they have an audio transcription of the whole conversation. And one thing that's lacking from old transcripts is a metadata tag of what specialization the follow-up appointment would be recommended for. So you go and have a general meeting with your general practitioner, and then they recommend you should see a neurologist, you should see an oncologist.
So what type of medical doctor basically you need to see?
Exactly. So in this case, it's a very simple fine-tuning use case, but the language model will take in a very long amount of language and then use that to output one of 10 classes. If you use a base model that's been tuned for chat, for example, it's going to give a big, long output. Thanks for asking the question. I'd like to tell you it's going to be oncologist. Right. That's not useful for adding metadata to our data set, which we're going to use in some application. So in our case, we fine-tune the model with a prompt that says, you need some labeled data. Here are some transcripts. Here are the labels we expect for these transcripts. Please make this, label. And the model is able to do that after very little fine-tuning work, right? So that's the simple one. It's full fine-tuning. In our case, you could
and you don't think like prompt engineering would work in this case to simply try to force it to say just give a single label back or something?
It's a good point. I did skip a step, which is prompt engineering can absolutely help you take a large open source model and perform this task. In our example, we could not get the 7 billion parameter version of Llama 2 to perform the multi-class classification problem. Okay. And so maybe Llama 3 is better. I don't think we've tried it yet. It's a bit of an old, one that we know works. But it's absolutely prompt engineering can work. And I think the combination of prompt engineering and fine tuning is what we see is okay, we see this prompt is getting towards it. Let's use that prompt in our fine tuning script, right? But telling the model you're going to tip it $20 doesn't always guarantee you're going to get a JSON output or something.
So first check, do you have a off-the-shelf model that actually do the task you're interested in? Then just go for it. Otherwise, try some prompt engineering, see if that actually makes your task work. The third step would be basically, okay, you need to fine-tune it to make it properly.
But help me out here. In layman's terms, when are we going in terms of prompting as a way to fine-tune and improve? And when is the definition when we actually move to fine-tuning? What's the difference?
So don't say prompting to fine-tune because it's two different things, right? So you prompt it to give the response you want without fine-tuning it.
Yeah. Okay. So I know what I said was correct, but you misunderstood. So what is prompting and what is its difference when we say fine-tuning, and when do we move from prompting to fine-tuning? What is the definition that separates fine-tuning from prompting? Because as you said, you had with prompting you can get so far. You can get a bit on the way in terms of fine-tuning in general but at some point you move over to technically fine-tuning. What is that in relation and not prompting that?
Yeah,
what is that? In
fine-tuning, you are changing the model. You are updating some or all of the weights in the model. In a way that moves it towards performing the task you want it to perform. Okay. So that you have, after performing fine tuning of a model, you have a new model. Okay. You'll have new files on your file system. Yeah. Prompting, you might have additional files that you might save. A lot of people will have prompt templates. So when I want to have the model behave like a software engineer, I use this prompt. When I want to have it behave like a blog post writer, I have this prompt. So
for me, the stupid guy, the difference between when we are improving our results with prompting, we are using an Swedish humor. Well, like if I don't know this in technical detail, I get lost here, right? Because what we are talking about an existing model, we are prompting it better and better. We get a better and better result. But when we say fine tuning, we mean going down and fixing and sorting and the model itself in terms of weights and stuff like this.
Prompting is so the way a user interface works. Somebody types in a question and they expect a response. Prompting or prompt engineering implies you're wrapping that input in some other text that you as the developer have defined. And people will call it the system prompt or something like that. It's fascinating to look at the system prompt that ChatGPT uses, for example. There are security researchers who will jailbreak ChatGPT and output the system prompt. And you can see that to guarantee the model doesn't help people create dirty bombs or mix drugs, they will have, just language in that wraps around every input to say, don't do this, do that, don't do this, behave this way.
So system prompts on top of your prompt as a user, right? Every time.
Exactly. So, prompt engineering or prompting as a skill, the reason why the term prompt engineer is now like a job title that people will hire is because people who become the model whisperer really get this intuition about how the model is going to perform in certain ways, and they'll have certain strategies. Like there's research papers written to show that if you tell the model you're going to tip it $20 or $200, its performance on mathematics tasks improves. But if you tip it 30 or 40, it doesn't. So models like 20 or 200, and maybe this goes back to engineering versus science, right? Like what?
Or psychology.
This is artistic here? What are we doing?
Also, I love to get more into, okay, let's assume that you actually come to the point where you need to fine tune and just go more into practical, ways to do that. But would you agree, before we go there, that like one of the big advantages, as I see it, for LLMs is that it doesn't require you to fine tune as much as traditional models used to do? Because if you took like an ImageNet kind of computer vision model, you had to fine tune it basically. Yes, you had no way to not fine tune it if you want to use it for some kind of classification task or whatever.
Yeah.
But now you can actually get away without having to fine tune at all in some use cases, at least. And that's a big advantage, right?
Absolutely. Yeah. When people will use the term democratization of AI, and I think this is the clearest example, which is to fine tune a model on that classification task that I was describing takes minutes in our demo, and it just works because it's a simple one. To pre-train the model to get it to the point where it can understand any text at all is, hundreds of years per GPU hour or something like that, right? They squish it down with a big cluster. But you hear, Llama 3 400B is training right now. They took a checkpoint and benchmarked it and then just let it keep training. Mark Zuckerberg said that the reason they stopped training Llama 3 70B is because they wanted the GPUs for something else, right? I mean, they could have kept training it. It could have kept getting better, but they decided just, use them for something else.
And Meta is basically buying a lot of GPUs now, and they are aiming to have 350,000 H100 GPUs at the end of this year. It's
already
insane number of GPUs. And if they are running out of GPUs, who else will be able to do the same?
Yeah, but let's go back to your question, Anders. Because this is the point. I was trying to understand what is the understanding of what we mean with fine-tuning compared to prompting, and we kind of got there. And now, what are the practical examples? Or a sharp definition of where fine-tuning starts, and some practical ways how to do it. That would be interesting to talk about.
Please continue on the medical transcript kind of example, and just say, how do people actually do that? Don't know how to fine-tune a model like Llama 3 or whatnot. How do you go about actually fine-tuning that to do the metadata prompting or labeling that you spoke about?
Yeah, I mean, how do we go about it? So the reason we're doing this in the workshop is because we released a new feature in the MLDE software, our development environment, called Gen AI Studio, which lets you do these fine-tuning jobs without writing code. You just have to specify the prompt.
I'm going to add a question later about no code versus coding, but because it's an interesting topic to me.
What's the difference between config and code? Yeah, there's lots of config,
but no Python code. You have Gen AI Studio, and it can help you to.
It's one of the many ways in which you could fine tune a model, and today we support one of the many types of fine tuning. So it might help to describe the two different types of fine tuning, which, it's very high level, but. In one case, it's called supervised fine tuning, and then in the other case, the simple one is called reinforcement learning from human feedback, RLHF, or DPO, direct preference optimization. So I'll do
what
the
about
first.
like continued pre-training kind of thing? Do you do that as well or support that?
Continuous pre-training is not supported in the Gen AI Studio product, but it is supported in the development environment product.
Okay.
So for example, Aleph Alpha, a large German startup who pre-trains language models, uses the development environment software I was describing to train their models, such as Luminous. And there's many reasons to pre-train. For example, for them to add in more multilingual data. They want to have the model perform well in
German, every language.
yeah, German, Italian, I think, Spanish, French. Yeah.
Central Europe stuff.
Yeah. Not Swedish. I'm sorry, guys.
Okay, but you have potentially continuous pre-training, and you don't need to have labels for that, right? That's
right.
a bit my point I'm trying to get to. But for the other two, you need some kind of manual work, some labels, right?
For supervised fine-tuning, you need supervision, right? Which comes from labels. So you need effectively a downstream task that you want to perform, which in the medical transcript example is the classification from 10 types of doctor. In an example, another one that I show for RAG, I use a police report. And so you can imagine extracting the name of the officer who wrote the report, or the type of crime, or when the crime was committed from a document. These sorts of things, you imagine you feed in 10,000 historical police reports and you want to categorize them with, labels like where they happened. Some stuff you can capture in databases, but some stuff is in this unstructured data and a language model can pull it out. So in those cases, you need labels, right? You need supervision. And you basically have an output that's expected from the model. So such as, here is the input, here's all of the data I'm putting in, the full medical transcript. And then because I, as a human, have labeled certain data, I can say the output specialist that I expect is oncologist. And
do you have in HPE some kind of tool to help with annotations or providing these labels, or how do you do that specifically?
Yeah, so we don't have one to actually do the labeling process itself, but assuming that you have code or an application that can run the labeling job, like draw bounding boxes around, objects in an image, or in the case of this, add a class in a database that you're going to track the data of. We have a product called the data management software built on top of Pachyderm, which basically allows you to automate these processing pipelines. Mm-hmm. So I mentioned Airflow earlier from the Hadoop ecosystem. Pachyderm, the history of it is that there was two guys who was working at Airbnb. One guy felt that the data processing pipelines should run on a schedule. They should run a query every day, every hour, or something like that. And another guy felt that data processing pipelines should run on a manual commit of data. Somebody uploads some processed data and then the pipeline runs. So one guy created a project called Airflow, and I believe still runs the company Astronomer, which is enterprise Airflow. And the other guy, Joe Dolliner, works at HPE. He created Pachyderm. Mm-hmm. So Pachyderm is basically Airflow, where the input is a new version of data. And it combines the concept of a DAG or a pipeline where one piece of code depends on another piece of code to run.
Do you remember Luigi, by the way? Back at Spotify ones?
Yeah. Luigi. I got some other ones. Argo workflows. We got Kubeflow. We got...
it's just my old memories of mine, so with the Luigi framework. Some people, I think Twitter is still using it, but I'm not sure.
Yeah, I mean, DAGs are really powerful for all sorts of things. In the machine learning context, our contention is that it's very important to tie a run of a pipeline to a version of data that caused it to run. Yeah. So you want to have a commit ID tied to a given version of data, and then have that traced through the pipeline so that you can recreate the processing later. That's what Pachyderm enables. It also does parallel processing native for Python only, where you can launch, let's say you commit a new directory in a file system to the Pachyderm repo. It has 10 files in it. You can launch 10 workers on the Kubernetes cluster to do it in parallel without needing to write Spark code or Dask code or Ray code to do the parallelism for you on the cluster. It kind of does it natively. Of course, you can still run Spark code if you want, but anyway, that's the product that we would position for people who are interested in labeling data. You likely have some raw data that maybe is a picture of a transcript or a raw audio file, and it needs to be processed in some way to get to the point where then humans label it or some automated service labels it, and then downstream of that, you finally train the model.
So in short, like supervised fine-tuning, for one, you need to get a label somehow, and you get that in some manual process or semi-automatically in some way. Then use a term or a tool like Pachyderm or something to as soon as some data comes in, you can start to process that somehow. Yeah. But then at some point you want to start fine-tuning a model as well, and or is that part of?
Well, assuming that you have the labeled data, now you can treat it like any other machine learning project where you can hold out, 80% of labels for the training set, and then have those labels be the expected output from the language model. So instead of, you send in this prompt, here's the full transcript, here's the input. The prompt says, provide me exactly one of these 10 classes. And the output is, thanks for asking the question. Here is the class, right? Instead, the expected output is oncologist. And after a certain amount of time, the model learns how to perform that task because it's been training on those labels.
Just get a bit more technical. Since I can hear you're technical as well, so I want to get a bit more deep there as well. Yeah.
He's always looking for this when he can have
any chance to go technical. Yeah,
we love it.
Dive in,
But then, okay, let's say you have labels and you want to start fine tuning the model. Let's say it's Llama 2 or Llama 3 or something, or some smaller models. But then you have a problem. You don't want to overfit it. So you don't want it to make it have catastrophic forgetting of the old data it has. How do you know, or can you get some help? Do you have some tooling around? Welcome here, but do you have some way? How do you know how to set up the training of the supervised fine tuning to make sure it's working properly?
Yeah, so the big thing is to make sure that the model is learning how to perform the downstream task and not actually learn the data set that you're providing it. So the correct, label that the behavior is what you're trying to train into the model. And so you have the cheers, buddy.
Cheers, Cyrill.
Welcome.
We're going to do the introduction soon, so let us just finalize the discussion.
For now, we're talking about the two different types of fine-tuning for language models. I'm trying to cover supervised fine-tuning and the importance of labels. You're trying to train the behavior rather than the actual knowledge. But do you
provide some preferred set of hyperparameters on how to do that? Or how should people know how to do that properly?
We have some recommendations, but the big thing with the tool is that we let the users configure the hyperparameters and really explore the output. So it has this concept of a playground where, metrics that you can build into a fine-tuning script of this type are useful to improve performance, but not, during training, but not always useful to get a effective evaluation of how good the model is going to be for your users, which is a combination of art and science. We described the difference between writing custom evaluations and using eval frameworks that are open source and we're looking to adopt, but also just quickly being able to get what I would call the vibe test, like roll it out to some users that are not, they're the experts, get their opinions on it, and then kind of use that to influence the next round of training with the next round of hyperparameters. So
awesome. And before we continue, speaking about RL, HF, and whatnot, let me just welcome here as well. Let me see, Cyrill Hug, is that the proper pronunciation as well?
Yes. Cyrill.
Awesome.
Cyrill. You're from Switzerland originally?
Originally from Switzerland, converted Texan now.
Converted Texan.
You can hear the Texan.
A Swiss Texan. I love that.
Awesome. And thank you very much for coming here. I know you've been working on the workshop throughout the day, and now you're coming here and having an after work. So that is really what we're doing here.
You're here to decompress now. It's okay.
Exactly. We've done all the hard work. We've done 6 stops in total, and we're good to go. Yeah.
Yeah. Awesome. So
yeah, we heard about the road trip and all that. So we had that background.
That background, yeah.
And we concluded this road trip is worth of a rock star, right? You know, one you know. So that's cool.
Yeah, a road show like Rockstars has.
You need a T-shirt, man.
And perhaps if you could, Cyrill, just give us like a 2-minute background about yourself. Who is really Cyrill Hug?
Yeah, I've been with HP for a long time, 12 years. I started as an apprentice. Before I was able to drink beer, I worked at HP in Switzerland. I was 16 years old. And awesome. I really focused on high-frequency trading solutions. So I was building high-frequency trading solutions for Swiss banks. That was obviously very popular. And I very quickly moved from being an apprentice in pre-sales to selling those solutions and then really consulting organizations and building those. Mm-hmm. And then...
If you could move the mic
a little closer.
Yeah, just move, if you could, yeah.
Is that good?
Yeah.
All right. Yeah. From there, I really started to develop an interest in like data solutions. Mm-hmm. Back then, we weren't calling it AI; it was machine learning mostly.
And this is 2012, or
roughly around that time frame. So 2015-ish. That's where I really got into like more of the machine learning part, and was given the opportunity to then move to Houston, Texas, as part of a relocation with the company, and that was in August 2019, right before COVID.
Yeah, interesting. And what was this setup or function that was being relocated? You know, what was it that went to Houston? Yeah,
the business of selling trading solutions to banks was going well in Switzerland, but there was a lot of potential in the US, specifically New York. And we had a dedicated team in Houston that was the engineering team. And then we had the team that was selling in New York. So I had the choice between New York and Houston. I chose Houston. Mm-hmm. And I was traveling a lot with a lot of customers back and forth. But then when COVID hit in like March timeframe 2020, I had a lot of time on my hands and I started studying data science and machine learning, got a bachelor's and then a master's. And that completion coincided well with our acquisition of the first software, which was Determined AI. And since then, I've been part of the Determined team.
Yeah, nice.
Awesome. Let us get back to the discussion we had. So we have a number of ways to fine-tune a model. We spoke about the supervised fine-tuning. Could we move, or could you please both try to describe a bit more about the RLHF? What is really about?
Yeah, I'll give it a go. I would describe RLHF as kind of the holy grail of fine-tuning. It's something that happens after a model has been deployed and you can get more human feedback. Supervised fine-tuning and creating supervised like labeled data sets is, you know, it's important and it's hard and it's sometimes expensive, but it's nothing compared to RLHF. The type of human feedback you're trying to find is basically a preferred response from a model where there is more unstructured response. You can imagine this in the case of just a chatbot where you're trying to get a response that's, you know, grounded in domain knowledge about, like I was saying, HPE servers or like some legal terminology, or we've seen this in pharmaceuticals where people want to, you know, have the model know about all sorts of different, you know, esoteric drugs and stuff like that.
And I guess it's hard for, if the output is a bit more unstructured, it's hard to give a single answer saying this is correct or not. So you need in some way to do something else. Right?
Yeah. Well, you basically need data from users, which is to say which response do they prefer from the model. Mm-hmm. And through that process, the model can learn some of the underlying not behavior the way I was describing it earlier, which is really a structure of like, you should perform this task, but just the quality of the response that people are expecting. It could have to do with the expected output, you know, it should be long or short, but really it's more about the content itself. The best example that I can, you know, provide in this case is, you know, from a friend who works at Google and worked on a feature that is effectively like a writing assistant. So you can, you know, have a model help you write a blog post or help you write some marketing copy or something like that. And conceptually, you know, this is a domain where the model is expected to be creative. And in certain responses, the model, you know, the users would vote up, this is a good response, or vote down. The other example I would give to kind of describe this behavior is in evaluation of models. So you guys familiar with the chatbot arena?
Mm-hmm. It's like a benchmark where you can compare the chatbots to each other. Yeah. Not really from a single number point of view, but just in terms of
what do people like better, right?
Yeah. So relative kind of measure in some way.
In the chatbot arena, you don't know which models are responding to you, and you get two responses. And you, as the user, who's effectively the provider of the benchmark, is picking which model you like better. And the way they judge these models is like they're playing a game of chess against each other. So whoever got voted for by the user, whichever model, it rises in the rankings. And so there's this, really pretty solid assessment of chatbots where you can see that, the new Llama 3 is climbing in the rankings, competing against other people. Who's in the top now? Is it Quen too, or who's at top? I'm not sure, but there are fine tunes of Llama that are out there. I was pretty sure GPT-4 and Claude were still at the top for the proprietary stuff, but just the concept of the chatbot arena, not necessarily the benchmark itself, gives you an understanding of what RLHF means, which is, again, human feedback or preference optimization for the more advanced types. The only difference is that in these cases, the model itself is providing two responses, and then you're comparing those responses to each other. Mm. So in some ways, the model is helping itself learn as opposed to just being compared to another model. So in simple terms, in some use cases, you can't really have supervised fine-tuning in the same way, since you can't really know what the exact answer is. And then you need to resort to like reinforcement learning with human feedback and then just ranking instead, right? Yeah, I think it goes both ways, where RLHF would not help for the medical transcript example, but vice versa. When I'm building a chatbot, I don't have labels of. It's actually not true, because there's a lot of press coverage that OpenAI has hired experts in mathematics and physics to, for example, label data that they found people asking questions about. People were asking very complicated math questions and physics questions, and then they were having people write out long answers that they would like the model to actually perform like. So there's a whole pipeline as you go from... Some jobs in OpenAI is not perhaps the most fun jobs. People with PhDs solving word problems? Yeah. Okay. Some people like it. I don't know. Not for me.
But then it comes back to different ways how the tool stack supports this, like in Gen AI Studio, for instance. So how can you support these different two, or which parts do you support? Yeah, what type of fine-tuning do you support?
The software is still in private beta, so it doesn't support RLHF today. but it's fun to talk about.
So one thing that we're looking into is, like Jordan mentioned, the human evaluation, right? And what you're looking actually to train is a reward model, right? That optimizes the actual model per se. We're not directly training the real model. So providing an interface to do that, collecting information, training that reward model, and then hooking it up to the actual training run of the real model that is chatting with you. Those are some of the things that we're looking to do in something like Gen AI Studio. But as Jordan said...
but I can fully sort of... On a theoretical level, it's like, okay, you need a thumbs up and down functionality that is really connecting back to the model or fine-tuning. That would be cool. So in practice.
Yep.
Are you going to, there are some other alternatives to RLHF, like a DPO, the what's called a direct preference optimization that I don't think require the reward model. Is that something you're going to potentially support as well, or...
I'm not sure if Jordan mentioned this, but on our team, we have a group of what we call applied machine learning engineers. Mm. So that's really a group of PhDs that is studying these kind of things. So direct optimization is certainly one of the things that we're investigating as well. I can't tell you exactly what we're going to release when, but certainly
it's on the radar.
We are doing research.
You already said it's on the radar. Yes. It's on the radar.
Exactly.
Awesome. And just to close off the topic, we started speaking about, how do you actually start, training the model in different ways, and we spoke about, can you find the off-shelf, model that you can use directly? Can you do some prompt engineering? Otherwise, you have to resort to some kind of fine-tuning, and then you have different types of fine-tuning, supervised fine-tuning, and reinforcement learning with user feedback, etc. Cool. Are these the main thing, or anything else when it comes to how can you potentially
I'll try
improve the model?
Yeah, I'll try and summarize. I mean, okay, there's many ways to improve the model. I think there's going to be more research done in the future. The thing I'd like people to walk away from here and say, okay, how do I build one of these applications, is a feeling that the application is going to improve over time. And just because you built an application that depends on Mistral today doesn't mean the next version of Llama is going to be better. And the way in which you fine tune the sort of skills you build, as we were talking about earlier, about how to work with these models, I think will just make these applications improve over time. So you add new data, you add new approaches to fine tuning, and suddenly the experience for users is getting better. Right.
Isn't that today, unfortunately, a lot of like an art form to know, now you actually can just use prompt engineering. Now you need to fine tune. Now you need to add more data to it. Now you need to change the model. I mean, how do you really know what to do to improve the performance?
Yeah. Well, I think it's more science, right? It's sort of a bit of a research topic as opposed to an engineering topic where it's repeatable. It's more like a manufacturing process. NVIDIA's CEO, Jensen, has a term for this. He calls it the AI factory. He believes that organizations are going to be just churning out AI applications that are going to be, secure and repeatable and things like that in the future. I'm not sure we're going to get there anytime soon. I think it's very much still a research topic, and there's spectacular ways in which these models can fail.
I have a hard time to say it actually is the research topic. I think it's a lot of trial and error today. It's more of an art form actually, but hopefully we'll. But
what you're meaning with that is that, okay, there's a lot of tinkering here, but we might need to have a scientific approach to it or a structured approach to our tinkering. And that's what you mean here, right? So researching opposed to this is a straightforward deterministic process. No, it's not. It's an exploratory process, and then it can be systemized to some degree. And then I agree with you, okay, but exactly how it is, well, that this is tinkering. Even you with a lot of experience.
I think some scientists, would say that what you do to develop these kind of AI models today is not really science, because it is just trial and error, and you see what works, and then it is not really a proper scientific method. But who knows?
Yeah,
you can argue both ways.
Okay, I think it could be like composing music, right? There's no correct answer, but there are ones that are preferred, songs or sequences of notes that are preferred over others.
In some way, if Spotify add a new song, it's very hard from a scientific point of view to say that this song will succeed or not, but you can put it out there and see actually what does work. And the same way with AI models, you can train them and change them and do the prompt engineering, but then you have to put it out to the users and see what the user actually like, and then but it's hard to really predict that without trying it out. Right?
Yeah, I see your point there.
I think that's an area where we see a lot of folks that we work with, getting to that point where we get user feedback and then have multiple versions out quickly is one of the things that we really focus on, and accelerating that feedback loop, if you will, right?
But isn't this one of the hardest things for an enterprise to wrap their head around when they have a fairly deterministic, all business cases needs to win kind of mentality, right? And here, actually you need to tinker, you need to explore, you need to experiment. But of course we need to do the investment smartly and all that. But it goes completely against the grain of the enterprise steering model. So how do you tackle these discussions? I assume you have them as well.
Yes. Maybe from my point of view, what's interesting with AI and machine learning is oftentimes the folks that build these applications are not the subject matter experts in what they're building for, right? So we need to be able to take the knowledge of these machine learning engineers in an enterprise setting and pair it with the business knowledge of people that will use this, and then loop it back. And that's exactly the challenge.
And the machine learning engineers, they will understand that this is exploration, but the domain expert, he hasn't really understood what this process is all about.
Exactly.
And gets
they know their domain.
They know their domain, and they know how to build deterministic systems. So what is this shit? Oh, come on. It's just, this is the way we work. You see what I mean, right? It's a clash here of culture or understanding.
And I think some of these people have been trained to use tools that are software-based and use the internet that are deterministic.
Exactly.
And they've gotten used to that. And now they've got to learn about a new tool that operates in the space of uncertainty and is sometimes wrong.
Yeah.
And so suddenly the same thing that you're looking at on a screen behaves like the intern you just hired who sometimes get things wrong. But I've just trained myself for 10, 20 years that this is going to be the exact same output every time I put something in. And now that's no longer the case. So I think it's a bit about getting the users to be comfortable using the tools in this co-development method. Thank you. In addition to actually making the tool itself, like we seem to want to have these outputs from these models that are never wrong. As if we're going to hire an intern that's an expert to work alongside us and be our assistant that's never wrong at anything. And I think that's just an unrealistic expectation.
Yes. Yeah, but and my thought process here is that people that is not sort of part of this, an AI practitioner knows how this works kind of deeply. They kind of need to be part of real projects. They need to get blood on their shirt. They need to understand it in order to really to hit home that this is not deterministic. I mean, like, I think it's a big challenge here that we are trying to explain it to them on PowerPoint. They don't get it until they have done a project. Would you agree with that?
Absolutely. I think the best example is with an FSI organization where we worked on basically answering their RFPs, right? They get RFPs from customers as well. And then these questions are fairly similar, but not written identical. And sometimes you get the exact right answer, and then you change a few words, a few tokens, and you get a different answer, right? And making sure that these people understand that use those RFP assistants is like, this is the first version. We need to provide feedback, and we need to treat this, as Jordan said, as an intern to teach.
Exactly.
An RFP is like request for proposals, basically.
Exactly.
Get into the company, and then you need to fill it out as quickly or efficiently as possible, or automatically.
Ideally, automatically. Yes.
Well, no, I think with the highest quality, and this is something I've seen in many cases, which is if a human user has a starting point, it's easier for them to edit an existing response to be better than it is to just look at a blank screen and start writing.
Right. Exactly.
And so I mean, people will describe writer's block. I don't know if sales reps can be empathized with for writer's block there, but me personally, like, I find it a lot easier to edit a response that's 80% of the way there than I do generate from scratch.
Could we switch gears a bit, perhaps? The time is flying away here as well. And at
Let's
some
go.
point, we are going to be a bit more philosophical as well and speculate a bit more about the future. But I would love, we spoke a lot about the training process here as well. And I know HPE also have a lot of tooling for more serving kind of purposes. And if a customer comes to you and say, why should I use your tool? So I can just, take similar question as before. I can just take an open source model and just, serve it. What's the problem? What would your reply to them be?
Yeah, I mean, there's a whole bunch of stuff that you don't get from running an open source model in a Docker container. You don't get scalability. One thing we demoed today, we had, I think, about 40, 50 people in the room, and one model copy on one GPU can serve the needs of, I'll say, 20 people concurrently asking questions. But as soon as you ask big questions with long input or expecting long output from more than 20 users, the response time's slow. So scaling up and down so that you can handle that load is important.
And then you're having some Kubernetes kind of way of doing this, or what's your solution to that?
The open source technology is called Kserve, and then we build an enterprise product on top. Yeah,
but that's based on Kubernetes, right?
Yes,
exactly. Yeah.
I mean, honestly, Jordan calls this the cloud OS. Basically, everything that we do in terms of serving these models uses primitives of Kubernetes, whether that's load balancing, whether that's scaling, replicas. All of that is, basically all the things that from running web servers. We kind of need running these models, right? Replicas, multiple versions, all of that.
Good analogy.
Yeah.
Okay, so scalability is one problem that you don't easily get, and you simply can't get by if someone without skills is just going to use an open source model and think that's it, right?
Yeah. The other thing is about a rollout. So, like you were saying, if it's comparable to a web server, updating the model and seeing what it performs like. We discussed as being rolled out to some users at a time, and then we need some feedback and see the response. This
like
is just
test group or something, or
exactly
like A/B testing kind of thing, or
so A/B testing, blue-green, shadow rollouts, canary. There's all sorts of different approaches that people use for like, click-through rates on advertising. Change the banner from blue to red, and now we get more click-through. I mean, the same approach for rolling out software that is a deterministic feature can be applied to a new model. And then beyond that, you need to log the responses. So right in this framework, you get logging of who's asking what question. You can anonymize it. You can store it, build data sets from it. So we talked about RLHF. How do we get that data? We have to get those votes up and down from users. We have to get good responses, bad responses, things like that.
So this is monitoring as well is another
like for performance. Yeah, absolutely.
Yes.
And then to tie it back to the scaling, right? Monitoring those metrics and then tying it back to a scaling factor. So are we scaling based on requests, number of requests? Are we scaling based on the memory that the model is using, right? So all those are things that we need to automate in an enterprise setting, and that's exactly where we add value.
But it seems to me as well also that people sometimes forget what makes a product usable and adoptable. And I sometimes use the analogy, think about it when we go to the supermarket. In theory, you can go and I want to buy flour. You don't go to a big container and use, take your flour and put it in your pocket, right? You get it in a container, you get it with a wrapper, you get it with a declaration, you get it with a price, you get it packaged in such a way so it's kind of easier to use. And I think people forget sometimes what goes into creating a product that is basically then
I think the number one feature we haven't covered with our enterprise K-Serve product is it has a UI.
With light and dark mode.
My favorite feature, light and dark mode.
There was actually
it has a calculator.
You know what?
And dark mode must be used.
Bluetooth enabled, yeah.
So if you're a hardcore engineer, it's got a UI, that's stupid. I want the prompt, But for the rest of the world, there's so much going on right now that, you need to go down to an editor and used to go away from that to a UX. Don't forget about that stuff.
Yeah. And if you think about who is oftentimes, especially when we talk about testing these models, deploying them to test them, right? It's machine learning engineers. Do you want to have your machine learning engineers running kubectl commands or Docker run commands? They're not in that level of the stack, right? So providing an SDK, that's exactly kind of the benefits that we deliver.
Yeah, so SDK means software development
kit. Basically a Python package that allows you to do create model. Right?
So even this point, right? We want our engineers to be working on this abstraction level. Yeah. So we want an SDK for the other stuff.
We talked about abstraction levels earlier, but you can tell Cyrill and I share a lot of opinions about things.
We had a profound comment that we sort of homed in on, that in the future now, coders, machine learning, whatever, you need to think through what abstraction level do you want to put your expertise on. And we had the example of, do you want to go all the way to CUDA, or do you want to go to, where do you want to be, right? Mm-hmm. And I think that's a good analogy then when you build a product. Okay, we have decided to build a product on this level, so then we need an SDK for this level. Yeah. And we need a UX that suits this level.
And we'll have specialization, right? So we'll have a DevOps engineer who is now the LLM model ops guy. Mm-hmm. So fine-tuning expert goes and spends all their time training models, talking to users, figuring out what's working, hands off a file to a DevOps guy who can go and deploy it on their tools, right? Maybe there's that level.
I'm super eager to go to actually that topic to see, but if a company wants to use HPE, what kind of team do they need? What kind of roles, what kind of competences do they need? ML engineers for sure. Do they need ML? Maybe not.
Depends a little, right?
Okay, so
I was
let's say they want to have an app for the medical transcript application. What kind of roles, competences should they hire for that team to build that system?
I still think you need people who are going to write Python code, but
I was asking the similar question from one perspective. What is the prerequisite level you kind of need to be at to kind of start owning these topics and take over it?
So, I'll give you one perspective. Jordan might have a different one. We have been building platforms for a long time that was really focused towards machine learning engineers that know their frameworks, know how to write Python code. One trend that we're seeing more and more is in the enterprise sector, folks that are maybe familiar with tools like Power BI, that know how to mingle with data, but don't necessarily have the Python skills. How do we enable those folks? Because we need a scaling factor, right? We don't have enough machine learning engineers in the enterprise. And that's exactly what we target with GenAI Studio. So if you have folks that are familiar with the use case, familiar with the data, we want to provide a tool, an abstraction, to your point, that allows you to build a simple app, an LLM app, without writing code. And I think that's where some of the focus areas will be for us in the next few releases.
But let's debate this. Because this is such a good topic, right? And let me put the Swedish spin on this. So the observation has been, who are the people that have sort of rebranded themselves as data engineers or data scientists? Where do they come from in Sweden typically, right? So typically we have a trajectory from BI, knowing a little bit of data warehousing, knowing how to configure data warehouse. So we were still using sort of applications, and we might be SQL coders. But my big observation is that when we put all these guys and girls in the middle of a cloud environment, a lot of them don't have the fundamentals in terms of software engineering and building robust applications. So they kind of have been taking out of it, I can configure a star schema, or I can do scripts for integration. Yeah. And now I need to build a compound system of different components that scales. And for me now, this is, okay, great, you take the BI guy into this, but they are not necessarily, in my opinion, trained software engineers.
BI people is completely different from this kind of team, right?
I agree.
So going back, what is the competence? What are the roles you think for medical transcript application kind of use case?
And this is kind of where I have a disagreement with Cyrill and some of our product team a bit here. But
there's a wet dream here, and then it's a reality.
Yeah. You're getting world according to Jordan here. Okay, first of all, I believe, and I think some people don't believe this, but I believe that like data engineer, machine learning engineer, data scientist are a subset of software engineer. Yes. It's a specific type of software engineer, but everybody who writes code, let's call them a software engineer, mostly, right?
I'm with you.
So in that context, I think that the first step for GenAI Studio and other kind of productivity-focused applications for building more and more AI-driven applications is to focus on software engineers who are not machine learning engineers, data engineers, but who write code. Let's say maybe this is somebody who works in React, or this is somebody who does Python for other backend
engineers. Basically.
Exactly.
There's a bunch of people who are web application developers, right? I can see them doing this trajectory, but this is not the same crew as doing the data warehousing and SQLing.
Yeah, they don't need to understand how the model is built, what this architecture thing means. They don't need to know how it's trained. They just need to operate in this world of uncertainty. Like the model may give a different response in different contexts, and then a world where the model is one part of a compound system, like you said. It is a back-end service we're going to call, and we're going to use the output for something else.
Yeah. So, okay, can I really challenge you on that to say that, okay, let's say now that Scania or someone were to build, not Scania perhaps, but some company were to build this kind of... Maybe. Anyway, Necco Health, perhaps. Okay, and some system or some company wants to build the medical transcript application, and now they have a traditional kind of software engineering teams. And they have the traditional type of engineers, back and front end engineers, and so forth, and QA engineers and whatnot. Could a traditional software engineering team like that just start using HPE to build an LLM solution like this?
Yes.
Yeah, I believe so, for sure. Yeah.
That's a strong statement, I would say.
Okay.
Yeah, okay. So let's have a debate. Okay, This is on one side, great. And what is on your side, Anders? Why not? I'm with them right now.
For one, I haven't tried your tools, so they could be.
Let's do it for fun.
In the optimal world, yes, I think there will be a point in the future where AI engineering will be, just as ubiquitous as any kind of engineering, and basically all systems will have some part of AI in it, and then it will be that kind of situation. But the tooling, I would argue, is not there yet, and there are a lot of things you need to understand in
There are things you need to understand. I agree. I don't agree that the tooling is not there yet. So when you start a fine-tuning job in Gen AI Studio today to perform the classification task from, which is the downstream task you care about, you need to input things to the model, like you need the data set that is labeled. You need an understanding of which model you are using. You need
how do you know which model to use? How do you know what type of data to have?
So that's the thing.
How do you know what labels to set up? How do you know what hyperparameters to use? How do you know how to serve the model to? I mean, how do you know what metrics to use? How do you know?
Today, if you purchase a software, we show you how to use it. Mm-hmm. So to build your first prototype RAG application, we expect it takes about a week. Yeah. The front end may not be very pretty, but it'll do something nice. Yeah. And I think that it's clear that there's a productivity improvement compared to writing the code yourself. But like, we support a small subset of models. We support a small subset of the different types of fine tuning. So over time, it's going to become more complex. But for the specific medical transcript application where we've already like built the code and demo it to people, I'm pretty confident people can click run once it's installed on their
but
stuff.
In the beginning, yes, but then it will come to the point that they need to improve it somehow. Mm-hmm. They need to have some data pipelines running suddenly. And then perhaps, can they really do that without having some data engineering skills?
Oh, no, they need those skills for sure. This is why I'm saying software engineering skills. Yeah.
I think there's a difference between exploration and getting started versus building a product that runs in production.
Right? Yes, that's a big difference.
That's a big difference. But I like to... I see two argument discussions going on at the same time, because at some point here is like, we can start with a software engineer with that has software engineering skills, and then we can sort of start with a product, and that allows them to get started exploring from their skill sets today. However, then maybe on a slightly different abstraction level, they need to comprehend the fundamentals around data engineering, data pipelining, and scalability and all that. So there is a skill acquisition needs to go on here. If I go all the way down to open source, is to me a fundamental barrier to entry. If you don't have some fun, you don't have the whole team of the different skill sets really together. So if I'm trying to steelman Jordan's side here, is a little bit like, yes, you can start with software engineering. Of course, they need to learn about machine learning and they need to learn about data engineering, but at what coding abstraction level do they need to start now? So do you see what I mean, right? So I think you are right in terms of they need to understand this, but it's the difference between sort of do you need to be able to code it to the most granular level, or do you need to really know what you're doing, and then you can use the tool to do the actual thunking, the real work. What do you think?
If I remember how I started, right, a lot of these courses are basically predefined notebook where you hit shift enter and you run one cell after the other. Mm-hmm. And then what you do is you start to tweak some of these cells and do some different things because you start to understand what the code does. I view Gen AI Studio, in our case, as a similar kind of thing. You start by a predefined template. All the code is exposed, so you can go and view the code. You'll start to learn, and you'll eventually graduate to someone that uses our API instead of the UI. That's the way I see, or I hope to see, the progression of our user base as well over time.
Yeah, I can just tell you before I work today, I worked at a company that actually built an AI platform, and that's why I'm having a rather strong opinion about this. But the goal there was really like no code, low code kind of use case.
I think they're both like, I have a big problem with no code software engineering. Like,
thank you.
Doesn't make sense at all to me.
Yeah. And this, go into the whole story, because you were in two different camps there in terms of thinking, who is this for?
How do we keep it short, I think it's awesome to have low code, no code kind of solutions and click and drop kind of interfaces, click and drag interface, but it usually makes people that are not, sufficiently technically not skilled to build the first prototype, to see, can you do this or not, to build a proof of concept. And usually that's rather easy to do. And that's great. But if you actually are successful in making this kind of, we have a class, okay, I shouldn't go there. No, let's take the medical transcript example. Let's say that it actually is successful and you have some proper users of it and see, this seems to work great, but there is a small problem here. Can we improve that and make this improvement a bit more better? What do you do then? Then I think low code, no code kind of solution is really hard to do. That's one point. Second point is that let's say that you have a even no code kind of platform and you try it out. Everything is in that platform and you run the model, you train it and serve it and you try it and it seems to work. Then it will be a point where you need to integrate it into the existing systems that company has. Who does the integration? It's engineers. It's not click and drag kind of users. It will be proper software engineers then.
Yeah.
That do that. So, and they don't like to have, click and drag kind of interfaces. They need to have some proper APIs or SDKs that they can use. So you need to have a engineering interface or engineering way of interacting with the solution you have, both for, integrating it, but also to improve it and monitor it and everything. So that's why I think, low code, no code is good to get started, but it is not sufficient to build a properly deployed solution.
Yeah.
You guys agree?
Yeah.
Absolutely. Yeah. I think so there's two reasons to do a no code, low code thing. One is to improve productivity of people who actually know what's happening behind the scenes, which we kind of discussed with the user interface concept before. I think there is a reason why somebody might want to just launch a job they've already written before that's captured as a playground and they can click because they don't want to log in and run a command. But then the other one is, an education thing, which is to make this available to a larger community of people.
That's a really good use
Get them inserted.
Yes. Good point.
So we're not, and I think that's a big reason why Gen AI Studio for HPE is a feature in the product, which we call the development environment, where the same GPU cluster where you can start this no code, low code thing, you can also start a notebook. You can also run a training job.
Yes.
Right. So
but then it's not really low code anymore.
But this is very important to understand, right? So the Gen Studio is a feature in a larger set of modules, where literally you would say, depending on the skill set of the guy going in, we take some of the user personas to the Gen Studio, whilst other might do the same stuff in the API hardcore way.
I see Gen AI Studio as a translation layer, essentially, an abstraction. So if you, under the covers, all the same API calls, all the same libraries, all the same callbacks, everything is the same in terms of what we actually use in terms of the capabilities, but it's just abstracted by a UI. So when you define your hyperparameters, when you define your learning rate, all of that stuff, essentially it gets translated to a YAML configuration file that in a manual world, a machine learning engineer would write by hand. In this case, it's just done by Gen AI Studio.
And if I understand it right, in your total stack here, if you have if you now go to a more advanced engineer, they can kind of choose where they want to go in and what abstraction level, what they're comfortable with.
They can even take something that came out of Gen AI Studio and tweak, because it's the same format, the same template.
This is good stuff. This is good stuff now, because also another way of discussing now what we need. It completely, it's like this is the socio-technical system of whatever organization you're going into, right? And sometimes we have what's the balance in the company in terms of software engineering, machine learning engineering, stuff like that. So now you can try to play to, okay, let's balance the team in this way, or now we need to recruit that. But I truly think, like you, Anders, we talked about this in Paltarion. You don't need to worry about the data scientists anymore. You can just give it to the domain. I'm like, come on, it's not going to fly. No. It's not going to fly, right?
No,
but you might be able to have less data scientists, or less super hardcore machine learning engineers.
No, I don't like that either. I think they're more productive. I think over time, there's more data engineers, there's more data scientists, they're more productive. I don't think we're reducing the amount of people working on AI in these organizations.
You don't need hundreds of them, you need fewer of them. That's what I mean.
Okay, maybe.
Productive. No, because the problem is, how can we recruit to the right amount of really focused we said it's software engineers, and then you need to go down to specializations, right? And you can't have hundreds of each, most likely, right?
Right. I'm just not sure that machine learning engineers are already automating themselves out of a job. Like we've seen this before with software developers. Like the better the website gets, the more people get hired over time. So I'm not confident that doing AI means there's going to be less people on the team. One thing I want to go back to that I just want to say the word, because Cyrill was referring to the layers of abstraction. We keep coming back to that. There's this concept of boilerplate code, right? And I just wanted to say the word boilerplate because I think it's important to say that more and more of this machine learning, the fine tuning code to run a fine tuning job for an LLM is boilerplate. And like you don't, for, way back, no matter what model you're training, computer vision, whatever it is, why are we writing custom checkpointing code? Why are we writing custom distributed training code? People know how to use libraries. They know how to use torch distributed or deep speed.
But you're a bit assuming that it's come down to some kind of, converged into these are the PyTorch specific library always use, and not saying that there are like 50 different other, libraries to use there. And are we really there already?
No, I don't think so. But that's Cyrill's point, which is, okay, we can run the default transformers fine-tuning job using an example. There are people who will have special fine-tuning libraries like Unsloth AI or like Axolotl, which has their specific way of doing fine-tuning, which implements some version of QLoRa, saves 50% of the GPU memory, makes it go faster. We're like, okay.
So many like different, it's still very an unmature market in that sense, isn't it?
So we don't support that stuff. And if you want to do that stuff, go do it with the APIs that underlie Gen AI Studio. Yeah. But the first time you want to learn about it, why not just use this tool that makes it a little bit easier?
But I'm more interested to hear now, you've been on a European tour, right? And then you you do these kind of workshops and similar demos. So that's whole setup. You've done it quite a bit in North America as well, right?
Yeah.
So, when you go home now and do a retro, where is the level of conversation if you want to contrast sort of first, let's start North America and Europe. And then if you want to go a little bit more, into Europe, are we all on the same level? Or, is it a very different crew that goes to can you have the same technical conversation in North America as in Europe, or is it the difference? So I'm trying to understand. We're talking about who's winning the AI race, right?
Well,
then it's like let's go back to normal people and normal enterprise, and where is the temperature at? So how do you sort of do a retro on these 7 countries?
The nice thing that I can say, so we've been to 6 cities in Europe, and I only speak English.
Yeah.
And so I can have these conversations in English with everybody. It seems
cool.
very hospitable.
That's cool. But that is, you didn't answer the question at all, by the way. But from an engineering point of view, and some sort of both who is attracted to come is interesting. Is it super deep in engineers in one country and it's the CEOs in the other country, and then kind of can you sort of pick a flavor? Oh, this is about the same level, or how do you see it?
So from my perspective, we have a mix of attendees, ranging from very technical machine learning engineering folks to like folks that are maybe new to the topic, or even decision makers
in the same room.
In the same room, which is interesting to begin with, right? Regardless of the location.
Yeah.
In terms of technical expertise, I would probably say it's roughly the same. Like we get good machine learning engineers in North America, and we got them certainly here. Yeah. Like the questions here that we got were very, very good. Mm-hmm. What I sense in general is the North American market is much more about how do I get started, how do I get these systems in hand, and how do I build the first use case, versus in Europe, where I sense much more how do I make sure I'm compliant and how do I make sure I do things right before I foot the bill for $1 million system, right?
So that's an interesting flavor of in conversation in itself, right?
I think, I would make a distinction. One thing I've noticed in both Europe and in the US is that we call on people who work for global companies, and they happen to work in the city we're visiting. So there's companies that attended in Stockholm today, which are not, Swedish headquartered companies, and they happen to be working on projects with people in the US, with people in Asia. So I think the world is becoming much more global in terms of the development of this stuff. and the access to information is absolutely global.
Yeah.
So we come to Europe and we say, who here has used LangChain? Who here has used Llama Index? And it's not like nobody in Milan has ever heard of LangChain because it happens to be on some, American server written in English. Like, it's absolutely out there for everybody. The funding, I think, is different in the US.
Yeah.
American companies are being more aggressive, fighting for allocation of GPUs, and now they have them and they're trying to figure out what they want to do with it. And here there are people who are still considering how they're going to get started.
Yeah. So in this sense, North America is ahead, not because of a skills gap or not because we couldn't do it, but it's the decision making around the projects and investments and what goes into the risk assessment that kind of right now you get another flavor in North America.
If anything, I would say that the most sophisticated users I've met with language models are in Europe.
Yeah, from a technical point of view.
Yeah, but I've been here most recently, so maybe I go back to the US and I say something different 2 weeks from now.
1 month.
Awesome. What's on the road ahead? What's next for HPE, Jens, at AI Studio or other tools that you have? What's going? Anything you can share about the future?
We're going to Las Vegas next week.
We're going to Vegas next week. Yeah, that's on the roadmap.
That's the big one.
I think in the vein of Vegas, what you will see is that much closer alignment with NVIDIA, and this could be a controversial topic in itself as well, right? Yeah. But I think NVIDIA right now is first front and center in many organizations, and they're pushing hard to get into the software landscape. They have great software frameworks in some areas, and in other areas they need a little bit of help. And I think HPE is looking right now to fill that gap where they need a little bit of help in productizing some of these frameworks, and that's going to be a focus area for us.
And we heard that your two CEOs will keynote in the sphere.
That's right. Yeah,
that's going to be cool.
What do you think about NVIDIA getting the dominance they have? They're getting close to be the most valuable company in the world, overtaking Apple and Microsoft and whatnot. It's kind of weird, isn't it?
Kind of weird.
I saw a LinkedIn post yesterday where there was AWS, Google, Microsoft, and then there was a shovels place. And then Microsoft, Google, AWS were all going for gold digging, and NVIDIA was selling shovels.
Classic story. Classic story.
Yeah.
Are you scared about that, by the way? That the concentration of power is going to like a few set of really...
No. I think this is NVIDIA. At this point, I believe the primary reason NVIDIA is ahead is because they have control over the supply chain. So
that TSMC or what?
TSMC, SK Hynix that produces the HBM that goes into these chips, and they have bought it out for another year, and they sell enterprise grade stuff. So NVIDIA is an incredible engineering company. They have a lead in almost all of the engineering aspects. But Google Gemini proves that you can train a frontier language model on silicon that's not produced by NVIDIA.
Yeah.
And so it's a matter of Google's business decision to not sell the TPU. And then it's a matter of AMD's aggression in the supply chain to not produce more of the MI300X. I would still, so I talked to my boss who has interacted with the CEOs of Intel, AMD, and NVIDIA in different formats. They all come to HPE for questions about servers and what's happening in the market, because we talk to people they don't. And he looked at Lisa Su at AMD, Jensen at NVIDIA, and Pat Gelsinger at Intel and said, I would bet on all three of them. I don't know how to pick between those three.
They're doing a good job.
It's still a few number of companies, and they will probably all succeed in some way, right?
I think we're if you care about the next generation of silicon and the democratization of AI to everybody, we're in a very good place with the leadership of those three companies.
Oh, I'm so eager to go more into this topic, but I'm biting my tongue here a bit. But you must be a little scared about the concentration of power to these tech giants, right?
To NVIDIA specifically, or to other tech giants?
And, not only the chip providers, but also to the big cloud providers and the big tech giants like Microsoft, Google, Amazon, etc.
I'm much more scared about that than NVIDIA, to be honest.
So I think distinguish between why are we more scared about the software-oriented ones than this hardware? What's the thinking here?
They control the user experience. If NVIDIA makes a lot of money or makes very little money, it doesn't affect my life that much, my personal life. And I care most about my family and my friends. When Google or Facebook or in some cases Amazon and Microsoft control how people interact with the world, that impacts my daily life in more profound ways.
I see what you mean.
I tend to agree with Jordan. I think we've seen some of this in the chip market before, right? With CPUs where Intel was very, very dominant for a long time, right? But the value actually gets generated on the software level. And I think there is a general expectation that over time, similar things to what with CPUs will happen to GPU markets as well. And then the true differentiator is on the software level that will define how things are performing, not performing, doing certain things, right?
Or how we
could I challenge that suggestion or that statement then potentially? I hope you're right.
Yeah,
I must say so. But given the latest kind of investments we've seen in compute infrastructure over the last X number of months, like Microsoft, of course, with $100 billion in Stargate, Meta, 350,000 H100 GPUs, XAI now 100,000 GPUs, H100 GPUs, OpenAI and Sam Altman saying $7 trillion kind of investments in infrastructure going forward. Google already had probably much even more compute infrastructure.
Yeah.
It sounds like, who can possibly compete with these kind of giants that have this kind of compute infrastructure?
So you're more concerned regarding the bundling of power on these providers.
They will build AI models that no one else can build.
Consuming any
independent on the software.
Yeah, but then now I think this is the point. Jordan was thinking, what are we scared about NVIDIA and the silicon? No. We are scared about.
I agree with you there.
We are scared about who is buying the silicon to have immense compute infrastructure power. Yeah. Well, this is a distinction, right? Yeah. Because NVIDIA is not doing that. They're selling this silicon.
I think we should have at least 3 different things: hardware, software, models, right? And the models now are the big tech giants, the few.
I think my response to this would be very different if Zuckerberg had not decided to open source Llama 3.
Agreed.
So at a conceptual level, it seems that open source wins. You get the power of everybody versus the one.
I agree with this.
Even the biggest models, and I don't think Meta will open source them either. So if you think about this compute infrastructure now being built, and they have trillion parameter models being built, you think they will open source that as well?
No, I just don't think that the improvements to go to a true dense trillion parameter model will be that much more significant than what we've seen so far. Oof. It seems to be diminishing returns at this point.
I do not. Okay.
You don't agree with that?
No, but
maybe we'll see some indication of this when the 400 billion parameter model from Llama 3 or Meta drops later this year. But
so that's going to be catch up with.
So what are you basing your ideas that is a diminishing return starting to emerge, and why don't you agree? This is a good one.
Because I believe that OpenAI trained GPT-5. It wasn't performing as well as they thought, and they named it GPT-4o and released it. And then all of their safety researchers left. And the CTO recently, Mira, said, we don't have anything that's in private that's that much more capable than 4o.
But it's been rumors about other people that left OpenAI recently saying exactly the opposite, saying that they're building something that we don't have the power to control. And they are so scared about what they're building internally, right?
Yeah, I guess I have to act on faith on that.
You know what? This is better than any soap opera. Come on.
But okay, just to give a bit of my view as well. Good. I think the trillion, parameter models hopefully will not be the winning thing. I think the investments they're doing in the insane compute infrastructure still suggests that will be the case. I hope that, just scaling the models with the transformer kind of style architecture is not going to be the winning thing. I think by adding this kind of reasoning, hopefully going forward on top of these, together with the transformer architectures, similar to Jan LeCun kind of ideas, and the energy models that he's proposing, and the JEPA architecture, will be the winning thing, and that can actually have open source being still competing with this. But that's a big chance.
So I think 2 things. One is that and maybe I have more information working at HPE, but in general terms, the big build out of compute is more focused on inference of existing models than training frontier models in the future.
That's actually a good point.
So I don't think you can infer that just because they're investing billions in more GPUs that we're going to see all of that for one hero training run where how long would it take you to get a response from a 10 trillion parameter model? Like, I don't understand the utility of that functionally yet.
That's actually a very good point. I agree. That's a good point. But I still, they could be trading these kind of massive models.
I think they will. I think they will, but I don't believe so I subscribe to the Rich Sutton, a nice Canadian guy, The Bitter Lesson, which is that the more and more time you spend thinking about software, the more you learn that you just need to wait for the next evolution of hardware. So I think about things in terms of the generation of GPU it was trained on. You can build a cluster that's a certain size with H100, and you can build a certain size with A100 and V100. GPT-3 was trained on V100. GPT 3.5 was trained on A100. GPT-4 and 4.0 have been trained on a combination of A100 and H100, to my knowledge. I don't believe we will see something new until Blackwell is out and massive. And from what I've seen for the Blackwell chip, it's not that significant. It's not an order of magnitude more performance over the H100 for training. There's nothing that says it's 10 times more performant for training. And so I don't think we will have a 10 times more capable model.
I like this analysis. I haven't made that connection so strongly before. I love that, Jordan. That is insightful. Well,
hopefully we'll have neuromorphic computing coming in.
Yeah.
So then we can go there.
Okay, so now
you made a comment earlier, which was my second point, about the concept of software improvements, right? And so all of this is scale all you need, right? So if we keep the transformer architecture and we just wait for scaling, we got to wait for the next and next generation of these GPUs. And we need something fundamental at the hardware level to make that next step. There is potential that we do it at the software level, but transformer was 2017 era.
Yeah.
When's the next transformer? Has it already been released? Transformer was pretty secret in 2017, and then we saw it on the public stage in 2020 with GPT-3 and 2022 with ChatGPT. What's the next transformer? Does it already exist right now? Is it something to come? I haven't seen anything that makes me think the world's going to end. You have your suspicions?
Not that we're going to end. It could be that it's going to bloom as well. But
okay.
No, but I have a big faith in neuromorphic computing. But
have you looked into neuromorphic? Have you? What's the? Yeah.
We have some people at Hewlett Packard Labs that work on neuromorphic computing. It's fascinating, and I did an electrical engineering degree, and I don't understand the posters that summarize what they're doing, let alone the actual details. So,
but Anders and I used to what Anders says, like, we have more faith in neuromorphic than quantum.
Yes, okay. Yes, much more.
I mean, that could be a level of, oh my God, quantum. You want to talk about things that are scary, right? But
well, I'm not scared about quantum, actually. So,
okay.
But we can go there after the cameras turn off.
But there is, I've been sitting here sort of, I want to ask a question, sorry. What at HPE now and where you're at right now, and now you're launching, with the launch of the new software stack and all this, so where is your excitement, or what are you, without revealing stuff you can't talk about in your roadmap, but what is sort of kind of, what is the buzz in HPE and Silicon Valley and, where you end up right now for 2025? What's the buzz now? So, because you said a couple of things that sort of takes down, well, we need better hardware, but things can happen on software level. But what is the buzz?
The number one thing that gets me excited about AI is where we started, right? Running these models potentially on your phone, on your own laptop, on a server that you control, having some level of independence and privacy. And, Cyrill, the resident American in here, will talk about liberty and freedom and things like that.
Independence.
Right? Exactly. Ooh. Yeah. So,
agentic stuff, is that something that you're working with? Or
something that I'm personally interested in, building some demos out. So that's definitely something that we're looking into.
Yeah. I heard a keynote from Luca Fries just 2 days ago. I was down visiting John.
Oh, really?
Yeah. So there was a couple of cool things, but Luca had like the summary, ended up talking and using the word agentic. And agentic has sort of not really got a foothold yet in, I think, in Sweden. So it's really the cutting edge people who's using this word. So what do we mean with agentic? Because I think this is part of the story here. What is agentic?
Yeah, for me, it's all about getting the right data at the right moment for answering, honestly, a prompt or some sort of a input, right? And what I've been playing with is, how do we do more than just document retrieval from a vector database, essentially? So if you look at building something for maybe demand forecasting, can we have an agent that goes out and writes SQL queries and get that information in? Can we have things that look up YouTube videos, transcribe it almost in real time and get information from that? So this multimodal component, getting in information is very exciting to me, because it opens up so much more than simply chatting with your PDF, right?
Yeah.
So I think we need to start to close off a bit.
Yeah.
Should we go for the final standard ending?
Yeah, I don't know. Yes, I think time-wise we need to, yes.
You've been here for a long time now. And,
it was all weird. I was late as well. I was stuck in traffic. So it's like, this is a monster episode in the making.
I had to finish the medical transcription use case with my workshop attendees.
Oh, you did that at the end?
We ran that today, yes.
Yeah.
Okay, let's go for the final, more philosophical kind of question. And if we assume that there will be an AGI future where we will have a system that is significantly more intelligent and knowledgeable than all humans, even combined, and we'll have super intelligence, more or less, what do you think that world will look like? Will it be either like you can assume a spectrum here. So in one end of the spectrum, it can be this kind of dystopian future where, you know, the Matrix, the Terminators, the machine will kill all humans kind of scenario. Or you can think the other end of the spectrum with a utopian kind of future where, you know, Elon Musk calls it the world of abundance, where we'll have goods and services for free. Energy and fusion energy has been solved. It's basically free. We have solved cancer and a lot of medical issues that we do have. Education is awesome and whatnot. And humans are free to pursue their passions and creativity as they see fit. Where do you think we will end up in X number of years?
You can go first.
You want me to go first?
Jordan.
Yeah, you led the witness there, and I understand that you view this as a positive future, and I hope it is as well. So I think the fundamental thing, I'll start with the negative, is that I see a lot of concerns with systems that are pre-AGI being a existential risk to humanity.
Don't worry about AGI.
You say exactly what I like to. Perfect.
Worry about the shit that will fuck up before.
Maybe you've discussed this before, but that's my biggest concern, and I'm very much somebody who is pragmatic and doesn't know how to think sometimes more than 1 year ahead, let alone 5, 20 years ahead. If we have a world of abundance, I think concepts like universal basic income and lots of like a future where we flourish and focus on creative tasks, exploration, things like that would be fantastic. I think one thing that strikes me traveling the world a little bit is the differences in human nature. We have been to 6 cities in Europe, and there was a different language spoken in every city, though people did converse in English with me. And I found that striking because I've had that same experience in Korea when I went to Seoul, in Singapore, in Australia, where they just speak a different accent. And, going on business means that you're very much welcomed by local people. It seems to me that one of the very nice things about being human is that there's distinct differences amongst our global population. And what concerns me about an AGI future is that we would all be melded into one, pursuing one mission, one goal, when I feel that a big benefit of AGI, or a multi-AGI future where there is a general intelligence for a certain organization, a certain group, and a general intelligence for other groups, means that we can continue as a species, as a globe, to pursue different objectives, things that we are individually interested in. So, to me, maybe that's China on one side and the US on the other side, and now it's a big war. But there is way to pursue different things while still cohabitating and respecting each other and benefiting from technology that both develop. So
cool. Great answer. And if I understood it correctly, because I usually say something similar to what you said,
okay.
I'm more worried about the pre-AGI time than after the post-AGI time.
We're having lots of problems with recommendation systems right now. That's XGBoost, right? Scikit-learn. Forget the transformer model.
Cyrill, do you have any thoughts about this? What's your concern?
I'm usually much less philosophical and much more programmatic. Yeah.
Pragmatic.
Pragmatic, yes.
And Swiss. That's why you're pragmatic, huh?
I think we as in the AI space, in the machine learning space, are very focused on our subject, but sometimes we tend to forget what's around it, right?
Subject, what do you mean?
So if you look at computer science, our day jobs, the people that we tend to interact with, obviously it's all part of our bubble, right? But there's much more that's going on that I feel like will not be easily replaced by something like AGI. So if you just think about all the infrastructure that we're building out, I saw an ad at a house. It's basically ChatGPT built me this house. Won't happen that quick, right? Those kind of things, I feel like there's a lot of grounded things that are still going to be around. Our life will change, certainly in the space that we are in. But when we go and take a look back, for the broader population, a lot of the jobs that are currently around, I know there's a lot of concerns about, but I feel like are still going to be around for the long term.
The jobs or the people? The jobs.
Both.
Okay.
Meaning that we will still be working and the work still has to be done, meaning there's probably not going to be something, in my opinion, like general income for everyone. There's just going to be a shift of focus of where we spend our time and what we're going to do with it.
Right. I like that point. I like to quote Gustav Söderström. He's like the CPO of Spotify. He said something recently that I thought was interesting. In an AI future, we spend a lot of time on stuff we have to do today. And we have to, be a bricklayer or whatnot and clean apartments and whatnot. But some people spend time on stuff that people want to do, like Netflix, creating movies or entertainment and stuff like that. And potentially the shift on what you do, the jobs you have, will move more into stuff that people have for entertainment rather than stuff they have to do.
Yeah.
I thought that was an interesting, because AI will do the stuff that, you have to do. People don't want to spend time on that because...
I just think we've already seen this in some ways, right? The more advanced societies in the world have more freedom in terms of how people spend their time. Yeah. But we've also seen that their populations have shrunk in many cases. So the more that the society as a whole is growing and trying to lift people out of poverty, the more the population grows. And then that turns around at some point. And I'm not sure we can blame it on the transformer model.
Maybe not. But, this is Elon Musk's number one concern. Before, Elon Musk's number one concern was AI. I think these days the number one concern he has is the decreasing birth rates.
Yeah, I'm less concerned about it. I think if people choose they don't want to have children, that's up to them. But I think it's nice from modern technology that we can have that choice. Yeah. But I think that having that choice enables results in a future that looks a lot different than what we have today, where some countries are going to shrink in population, and that's going to mean the world's going to look a lot different.
Awesome. Thank you very much, Jordan Nanos, right?
Yes.
And Cyrill Hug. It was an awesome experience to have you here, and thank you for actually taking time, even from the workshop you had today, and come to join us on our podcast. Thank you very much.
Thanks for hosting us.
Thank you, guys.
Yeah, thanks.